Welcome to Class Objects and Pointers. Now, in this video, I want to introduce you to the concept of using classes just like we've done before. But notice, and now I'm using the example very similar to the one that I used in the Virtual Function Basics videos. Okay, so understand we've got a virtual function in here. Got your little note in here. Without virtual, the Persian check age is not called. And oh, by the way, this is all in a solution. This is in a solution in a project called Object Pointers. The code is in an obpoint.cpp file. You will find this out there in your work files folder, okay? And I would go get this one in work files because there's a little bit of code here, all right? But notice we kind of did this the old-fashioned way, okay? We went out and created a instance of cat at C1. We sent C1's variables or properties different values, and then we called the inoculated from C1, and it did its magic with the check age and all that, and everything came out just great. All right, then we created another class called C2. C2 is based on the Persian, which is inheriting from the cat, and we went through the same thing. Now let me run this just to let you see that it runs, everything's okay. If I go out and run object pointers, notice from the cat class, yes, the cat's been inoculated. And then from the Persian, no, the Persian has not been inoculated. So our virtual functions are working. Everything's okay. We're getting what we need. But is there a neater, kind of a cleaner, cooler way to do this? Well, yeah, there is. And it's a little bit easier. It makes it almost polymorphic based on how you're using it. And that is to use pointers to point to these particular objects right here. And so to do that, let me just show you. I'm going to comment out this stuff. Okay, so comment these out, and then notice I'm leaving my object instantiation lines up here, and I'm going to come down here, and the first thing that I'm going to do is create my pointer. Okay, so I'm going to create a pointer to the type of cat, and that is my base object up there at the top, and I'm going to call it POBJ. All right, and I'm going to instantiate it to null, so null PTR. All right, so I don't get any surprises. Now what I am going to do is I'm going to go back and I am going to set PObject, POBJ, equal to the address of C1. All right. Now when I do that, I can first of all set the POBJ, set some parameters on those. All right, and I can set the age of C1. Now notice if I hit period, I don't get anything, because since I'm using a pointer, I have to use the indirect member selector, and that is the dash and the forward arrow, okay, or the greater than sign, if you will, and notice that exposes them to me. So I can set age here equal to, and we'll set age equal to 5. Okay, for Fluffy, because we're dealing with a C1, and we would later name him Fluffy. That's what we did up here, but I'm not going to do that now. Okay, what I am going to do is I'm going to call a different console out here, and I'm going to come down and I'm going to type this in. Notice that we're just going to do a standard console out, and notice we're calling PObject, but we're calling inoculate. All right, and when we call this, it's going to jump up here, it's going to call inoculate, it's going to check age based on what M age is, and it's going to look at the address here, and it's going to make magic happen. Okay, so let's go run this and see what we get. All right, and so we'll let it compile, we'll go out, we will grab it, we will run object pointers, and it says yes, the cat has been inoculated. The cat was 5. If we look at the check age up here, it's greater than 2. Whoop. It's greater than 3, so the cat has been inoculated. Okay, well, what happens now if we take the same code and we now set PObject equal to at C2? All right, and we're going to call the same thing. Okay, and notice now I'm going to copy them so you can see the importance of this. Let me copy them. I did that again. We're going to copy. Then we're going to paste down here, and by copying and pasting those, you can see the significance of this. This is the only thing that has changed, okay? And so I will compile this, say yes. And the difference here is the first time it runs, the object pointer is pointing to the C1 or cat class, and the second time, you notice if you just mouse over it, you're pointing at the Persian class, okay? So let's go out to our window here. Let's call object pointers, and notice the first one, the cat has been inoculated, and then the second one right here, yes, the Persian has been inoculated. If we set that age down to 1 for the second class, which is the Persian, and we recompile, we're going to get a different answer. But I hope you can see the possibilities that you have here with using these pointers. Notice here now, no, the Persian has not been inoculated. This gives you a lot of leeway in using one common object here, which is really the pointer, to point to different objects. But by calling basically the same lines and the same things, all you have to change is the pointer to get totally different results out of that. Okay, so that's just a real simple example of using pointers with your objects. In this video, and this is probably going to be a fairly short one, I want to talk to you about pure virtual functions. Now, I did this in a separate video because I wanted to get your attention with it, and I want you to pay close attention to this. Now, before we talk about pure virtual functions, let's back up just a bit and let's talk about a virtual function. Now, I talked about those in a separate video entitled Virtual Function Basics. But if you remember, a virtual function is a function that we put in a base class that we basically mark it so that it can be redefined in a derived class or in a class that's inheriting from this class. All right? And so virtual function was pretty cool. Now, a pure virtual function kind of takes this a step further. A pure virtual function is not a function that can be redefined in a derived class. It is a function that simply must be redefined in a derived class. We're going to basically put the signature with a little extra stuff in there on the pure virtual function in the base class, but we'll put no operational code whatsoever. So it's like a function without any code that runs when it gets called, all right? And so obviously you can't call that function. But that is a pure virtual function. So the first question that comes into your mind is, well, wait a minute, what's the big deal? Why would I want to use a pure virtual function? Well, very simply, most often it is to ensure polymorphic functionality in all derived classes. In other words, in the simple examples I've been using for the veterinarian's office with the cat class, let's say that cats get inoculated. But different breeds cats get inoculated at different ages, they get different dosages, they have different diseases, whatever. I have no idea, I'm not a veterinarian, you can probably tell. But we still want the same inoculate function in all of our derived classes off of this base class. Well, we would put a pure virtual function in the base class, and when we talk about abstract classes, you will see how that ensures that every derived class uses that one particular function call, and then we can make sure that we have the same calls, that we simplify. We have our standard, organized, well-designed object model, but we're still providing polymorphic functionality to all of our derived classes just based on this pure virtual function in the base. Now, here's the bottom line, and this is the perfect segue into another video. The presence of a pure virtual function makes a class abstract. Now, if you know what an abstract class is, it just turned the light on for you. If you don't know what an abstract class is, then we just need to join me in the video entitled Abstract Classes. See you there.